Berst of SmartGridNews, and we're going to finish with answers to your questions. So here's a question from Matt, and I'm going to start with Ranjan, but then I'd like Forrest Small of Bridge Energy to jump in with his viewpoints of the industry at large. And the question is, prior to engaging Bridge, did you rely on predefined OMS and SMI smart meter product vendor integration methods, and how did that work out?
The short answer, I think, would be, and high level would be yes. We took the SMI data and the interfaces supplied by Itron. We took the products supplied by PowerOn, which is our OMS, and according to their published specs. And we did that, I'll call it vanilla integration. So when we started, yes, that was where the initial focus was, as it should be, both to understand the products at that level as well as how it would actually work from a real-world perspective, not only time spans, but user interface and potential adjustments to process. We needed to do a bit of an impact assessment, and that helped us do that.
And Forrest, what's your wider perspective? Is that something folks can rely on typically?
I think it depends to a large degree, Jesse, on the kind of technology you're talking about, and importantly, the relationship that you might have going on with your vendor. This is definitely one of the areas that we work in, AMI OMS, but we also work in with OMS and DMS. And what we've observed is that vendors have good solutions for their product, but naturally they have to make a lot of assumptions about what the utility is probably going to have so that they can utilize it. And what we're finding is that utilities really want something that can be a little bit more customizable, and that can be pretty challenging to do on one side of the equation with one vendor. We've actually had some engagements where the utility is actually trying to talk with vendors about what's coming up, what's coming down the road, what kind of capability do you have, because we're going to move out on our own kind of customized integrations, and we just want to understand where you're headed. So I'd say at this point, if you're doing more highly intelligent integrations, it's probably going to be challenging to do that directly with a vendor, but certainly every case is going to be different.
Terrific. Well, I've got a series of questions that are all kind of related to major events and storms, so let me run through them, and then maybe start with you, Forrest, and we'll see if Ranjan wants to join in as well. Differences between a small-scale outage and a large storm. Do you use the same methods no matter how widespread? That's one question. Related, how do you isolate good signals from bad in a large storm? Also related, how do you handle outage volume in a storm? And finally, do you throttle back your AMI during major events? And if not, has the system ever been overwhelmed? So Forrest, to start with you, can you give us a little more color on large events?
Sure. And I think this is going to be a combination of what's actually happening now and where utilities would like to take it. And I think the short answer is that the dream is kind of to have the same sorts of algorithms and the same sorts of capability automatically coming into play for outages of all sizes. So that would be, big storms or blue sky day, singles. So I think that the reality is most utilities are probably doing some kind of throttling, or some are probably even turning off some of the more advanced capabilities during large storms. And that's just because they probably have a pretty good idea of where the damage is and what they need to do to get started. Having said that, I think Ranjan mentioned it before that, being able to really look at the network and try to understand the scope and extent of damage using these smart meters is going to be pretty valuable. I think one thing that I would point out in terms of the types of benefits that you can get, when we started, we talked about, the impact on reliability. We talked about the impact on operational efficiency. I think a lot of the operational efficiency benefits, the cost savings and things like that will actually happen maybe more likely when we're in blue sky day outages where the utility isn't necessarily expecting anything to happen. And the technology can do a whole lot of good for trying to help them figure out what's going on and not roll trucks and not do those kinds of things that they would naturally be doing during a large event.
Ranjan, anything to add in terms of major events?
I think the other thing to add is we talked about it a few times. I think we probably said the word process quite a bit. But one of the things we tried to do quite deliberately is ensure we engaged their restoration group, the actual department that's responsible for the dispatch and management of the distribution outages, all along. So they were part of the trip, as it were, as we went through and we identified these issues, and we really asked them, look, how are we going to make this work? What do you guys need? What would you like to see? And as most utilities are likely different, blue sky versus storm events, there's the actual restoration process, but there's also I'll call it the upstream around, whether it's management or executive or even from our smart metering device operations. Different people have different perspectives on the information they want to see. So we're trying to understand what that is so we can provide the so-called right tools to the right people.
Right.
But really, we're just starting down that path, as it were. And I think we've got a number of tools and we've got the right experience. Now we're just trying to understand how we can implement the right solution without overwhelming people.
Well, maybe this is a good time to bring up this question by John, who asked if you'd say more about process changes. Which groups are involved, customer reps, service dispatchers, restoration, and how do you communicate to them? Lainey had a related question. She wanted to know what the AMI operations group does during outages and how has that changed as a result of this integration. Ranjan, maybe we could start with you.
Sure, that's an interesting question for BC Hydro. We're in the tail end of our project, of our implementation. As I went through in the first couple of slides, the bulk of the meters have been deployed, and we're just in our final stages of optimization, but we're still deploying our transformer and feeder meters, which will help with outage. But our operations group that's been formed to operate the smart meters, the other devices that will be going on that network, is going to be moving as part of our grid operations group, which also contains our outage management restoration group. So not only part of the same department, but in the same physical location. So as we move forward, the intent is to really, as that question implies, to understand how we work closer together, because these are all devices in the field. These all have field impacts. We need to make sure we're providing the right information, as our objective says, reliably, but make sure we're enabling the dispatchers to make the right decision. And they are already quite closely tied to our customer service agents in terms of handoffs of call taking, et cetera, depending on whether it's office hours or after hours, and the emergency procedures and protocols that are in place to support that.
Forrest Small of Bridge Energy, anything to add?
Yeah, I guess, Jesse, I'd just point out that, one of the things we see is that a lot of this technology, particularly the recent smart grid technology, had to go in over a long period of time. Business cases were developed by teams that were very focused on certain kinds of outcomes. But by this point, the technology is kind of back in the hands of the business operation, and it's not always clear exactly what we were after. So it's really time to get engaged with the business operators, and as Ranjan said, let them tell us, what are you looking to try to do differently? If you had this kind of information, what would you do with it? What would be different? Remember that these are end-to-end processes, and the technology often got installed in silos. So a big part of what we do is getting right into the trenches with those teams and figuring out, what information do I have that you need? What are you going to do with it? Where does the technology play? Where does a human being actually have to pick it up? And then making sure that it all makes sense and it drives out the operational efficiency.
So Ranjan mentioned transformer monitors as one thing he wanted to bring in addition to meter data. And so would both of you say a little more about other sensors that you might want to incorporate eventually and other data you might want to bring in, like weather and so on? And for instance, Rita asked specifically about check meters on the side of a transformer to check power flow analysis. But just maybe a slightly broader view, what other information could really enhance this?
Well, maybe I'll start and Forrest can augment.
Please.
Just taking the tail end of that storm discussion, we've also implemented a filter where we would be able to either block the outage messages coming to the OMS so we don't impact operations, or at least scale it back to say don't provide any more than, say, N number of messages from a given transformer or an aggregate level, so we can throttle it a bit. So the second part of your question was more related to other devices, and I think depends on your technology architecture, but from BC Hydro's perspective, the network deployed to support our smart metering solution is intended to also support future DA devices. Taking a step back, our feeder and transformer meters are metering devices. We should be able to get events and or interrogate to determine if they're running on batteries, for argument's sake. So that, in combination with the status of meters in the same area, should give us some better intelligence. But as we deploy more distribution automation type devices out there, the intent is, whether it's from an event or an interrogation communications perspective, all those devices potentially are going to be able to provide more information and telemetry for us to understand the state of the system.
And Forrest Small of Bridge, anything to add?
Yeah, I think the only thing I would add, Jesse, is that I agree with everything Ranjan just said, and it's definitely something we can do from the point of view of sensors, but I think we envision a future where we're actually driving a lot of this with the business analytics, where we can predict where outages are going to be, and we can go looking for them, whether it's failed equipment or storm patterns or other kinds of stuff that we can use to triangulate on those outages and really quickly tell the difference between a problem and not a problem.
Yeah, excellent point. Everything points to predictive as the kind of the next major step forward. Well, we've got more questions. We're going to have to answer those in writing. So that's our time today. So it just remains for me to give a very grateful thank you to Forrest Small of the Bridge Energy Group, as well as Ranjan Raja of BC Hydro. Thanks for all of your great comments and helpful advice. And thanks to all of you as well for joining us today. This is Jesse Berst of SmartGridNews signing out.